Wait for it.
Good afternoon, everybody, and welcome to our Science Engaged Day. And good afternoon for those of you that are watching. We are broadcasting live from Little River Elementary School in Durham, North Carolina. Little River third graders, can you say hey to everybody that's watching right now? Excellent. We are so glad to be here. Thanks to these wonderful teachers for bringing it out today. When I say class, you say yes. Class?
Yes.
Class?
Yes.
Yes. Again, good afternoon. My name is Dr. Drizzle, and I'm going to be your guest scientist today as we study a little bit about third grade plants and soils. I know that you've been studying that already, but if we'll look up here at the screen, this is our game plan for today. We're going to talk about how we're going to use our journals. We're going to participate in something called mystery science to solve an essential question. We're going to read a little bit about coconuts, and then if we have time, we're going to talk to and watch a little bit of Bill Nye the Science Guy. Give me a thumbs up if that's okay with everybody. Excellent. So talking about Bill Nye the Science Guy, I've actually met him a couple times, and he's a wonderful person. When I talked to Bill, I said, Bill, because like we're just on a first name. He says, Bill, what makes a great scientist? And he put his finger right here, and he looked up like he usually does when he's thinking. And he said, well, usually scientists will do something, and then they'll talk about it. And they'll usually draw it out, and then they write about it. And I said, well, that's very smart, Bill. Thank you very much for telling me that. Well, he is very smart, but I wanted to check with some more friends of mine. And some more friends of mine I had were Adam and Jamie from Mythbusters. Any ever seen them before on the Mythbusters channel or Discovery? Absolutely. So I said, Adam and Jamie. And at the time, I also asked Carrie Byron, who was with them too. I said, what makes a great scientist? And they went, well, a good scientist will do something, some kind of experiment, and then they'll talk about it with their colleagues. And then usually we sketch it out, and then we write about it. So that was 4 different scientists telling me about what good scientists do. So we're going to adopt this. This is how we're going to work today. We're going to do something, we're going to talk about it, we're going to draw it, and then we're going to write it. So the first thing we're going to do today is we're going to answer an essential question. Now, I do realize that the computer is kind of messed up with the screen, but I think we can read this. So I want you to, for those that can, read this question with me, starting with the word how. Ready?
How did trees travel halfway around the world?
Now, before we even go into this mystery today, I want you to discuss this with a partner. But let me share something real important with you. When I was in school, I loved science. I loved everything about science. But here was my problem. Sometimes when we talked in small groups, I got left out, and it hurt my feelings. So it's okay now because now I'm grown up. I am a scientist. But today, when we're working together, and I ask you to turn knee to knee or nose to nose or to a partner, make sure that someone behind you is not left out. Make sure that they all have someone to talk to. So scientists, right now, would you please turn to a partner and discuss this question, and let's see if we can solve it. Go. So those of you that are watching in your schools, what questions did you come up with or what answers did you come up with? Let's see what the river thinks. So who has an answer for me? Yes, sir, in the black t-shirt, gray t-shirt.
The wind blew seeds.
The wind blew seeds. Did anybody else have something like that in their repertoire? In the striped shirt, yeah, ma'am.
Like some seeds kind of like blow like dandelions. You blow them like their seeds so they blow around the world.
Okay, so what is your name?
Sarah?
Sarah, did you find my lesson before I came? Have you already read all my stuff? And now I can't even do my lesson because you already know it?
No.
No, I'm just playing. That's good. That's very good. And dandelions as they come up in just a little bit. Yes, sir, in the back of the white t-shirt. Real loud.
Maybe the life cycle of a seed, it probably travels all around the world.
Nice. I love these words that you're using. You guys must study science here. Gray t-shirt in the back.
It gets carried by the wind.
It gets carried by the wind. So there's so many more people that have their hands up. So here's what I want you to do. Would you take 2 minutes and 10 seconds to write down the question and then answer it like you would have answered it had I called on you? 2 minutes and 10 seconds. Good job, Tim. For those of you that are watching back in the classrooms, I wish you could see this, but we have got about 68 third graders that are not speaking and are writing their little hand off trying to answer this question. That's exactly what we want to see as scientists. People that can talk and understand things and then write it down. That is absolutely amazing. Good job, guys. Proud of you. Way to be a scientist here. Something else we're going to do before we actually start the mystery science is we're going to do something that Adam and Jamie will like. They're on a TV show called The Mythbusters. Now, the Mythbusters do two things. They find out something that people want to know, and they either bust the myth, okay, or they confirm the myth. So right now, you've written down what you think happens with a seed. So we're going to find out the rest of the time together if you're going to bust the myth or if you're going to prove the myth or confirm the myth. So if you watch right up here, I'm going to actually move to the back so I can view the computer, and we're going to find out a little bit about how seeds move. And every time you hear something on the video that actually confirms what you have said on your paper, would you please let me know by just putting a check mark in the air? Let's just practice that now. So if you find something that is true, that confirms what you just learned, everyone give me a check mark. All right, a big check mark in the air. Like you're right one. If you see something that makes you think, uh-oh, I was wrong on that, give me a big X. And guess what, guys? That's okay to do. In fact, Jimmy and Adam will tell you that failure is always an option. We don't learn unless we make mistakes first. So we're going to start right here and start.
This is the Explorer ship, HS Adventure, about to set sail around the entire world. On board is a group of sailors. Their plan was to sail from the Hawaiian Islands, that's here in the map, and then sail all the way around the globe, running back to Hawaii again in under 3 years. The very last thing they had to do before leaving on their journey was to build a figurehead for their ship. This is a figurehead. A figurehead is a large wooden decoration attached to the front of the ship. The crew of the HS Adventure was excited to carve their figurehead from a special kind of tree found only in Hawaii, a tree the Hawaiians called the koa tree. The wood of the koa tree, seen on the inside when the tree has been sawed, is a beautiful shade of red. Again, as far as anyone knew, Hawaii was the only place in the world where koa trees could be found. And so, with the figurehead carved, off they went on their voyage around the world. They made it across the Pacific Ocean and almost all the way across the Indian Ocean. Everything was going so well until one night, storms created huge 50-foot waves. The first of the waves snapped some of the wing boards on the side of the ship. Once the storm ended and the sea calmed down, the crew of the ship saw the damage. Entire sections of wood had come off and were lost at sea. Water was leaking in. The sailors were terrified. They needed to act quickly. They needed wooden boards to patch up the leaks. Luckily for them, off in the distance, an island was spotted, and most importantly, there were trees on it. One person on board was especially excited. He was Joseph. Joseph wasn't a sailor. He was the ship's scientist. As ship scientist, his job was to discover and collect as much as he can, especially about plants and animals that have never been seen before, and then bring his discoveries back to his home country of England. Joseph was excited because this island they were about to land on was a new island. No one had ever set foot on this island before. It was going to be an alien world, and he'd be the first to see it. And from the moment they landed, he started with all kinds of things he'd never seen before. There were animals he'd never seen before, like this, today called a panther chameleon, or these giant tortoises. Even the flowers and bushes were totally new. There was nothing quite like these in Hawaii. This island that these are on is known today as Reunion Island. You can find it here on map, in the Indian Ocean, about 1,000 miles off the coast of Africa. As Joseph collected samples, his sailors were busy looking around for the best wood to repair the ship with. They found a type of tree that was large, with sturdy, solid wood. It was perfect. So they chopped the tree down. As soon as the tree fell, Joseph went over towards the top end to get close to the branches. He wanted to look at the tree's leaves and flowers to see if it was something new. Whoa, he thought, These are flowers that look new at all. They look so familiar. Where have I seen these before, he thought to himself, scratching his head. He pulled out his notebook and realized that these were the same flowers that he saw on the tree that they used to carve the figurehead from back in Hawaii. He walked back down the tree's trunk where the sailors had cut the tree, and sure enough, when he looked, the wood was red. It was a koa tree. How could this be? Look how similar the trees are. Koa trees are only otherwise found in Hawaii, 10,000 miles away. That's only half the way away from Reunion Island. That's the other side of the world. How could the same kind of tree be in both places? It's almost as if the trees had flown across the ocean. But we all know trees can't fly. How could koa trees have gotten on both these islands, half a world apart?
So, how do you think that these koa trees could be in two different places, half a world apart? Before we share out, 2 heads are better than 1 and 3 heads are better than that. So, will partner discuss that question? Go. And we're back. Who wants to raise their hand and tell me how you think this happened? What your partner might have said. Yes, in the black sweater.
I think that the koa tree dropped flowers, and the flowers had seeds in them, and it grew in the wind, and it like landed on another island, and then landed another koa tree, got more flowers, and they all got scattered by the wind in different places.
Okay, so you think that the seeds were scattered by the wind. Excellent. What do you think, sir?
Well, I think the bird ate and then traveled halfway around the world and then used the bathroom and then came out.
Hey, we all poop. Yeah, if you don't, you're in trouble. So you think a bird ate the seeds and then flew across the ocean, and when he had to go and pooped on the island. Not bad. So I know there's a lot more answers, so would you take 1 minute and write down your answer? This way everybody can participate. Write down what you think. Now, if you didn't have an opinion, if you weren't sure, but you liked one of the answers of one of your colleagues in here, then take that answer. So we had a couple of answers. We had one that the seeds were dispersed by the wind. And the next one we had one about a bird and pooping. So let's see what happens.
Plant and animal on Reunion Island is different from those on Hawaii. So it must be that some koa trees traveled across the ocean. But how did koa trees get across such a long distance? Trees themselves are huge. The easiest way for any plant to get from one place to another would be for its seeds to have been moved. Seeds weigh very little, especially compared to an entire tree. Imagine if somehow the seeds of a koa tree got moved from Hawaii to Reunion.
So if you said something about seeds and it's confirming what you said, go ahead and give yourself a check mark because you're confirming what you just heard, and let's keep going.
Once they landed on the island, they might have started to grow. And then there'd be koa trees on Hawaii and Reunion Island. But how could the seeds have traveled halfway around the world? It sure wasn't the sailors who brought them. When they landed on Reunion Island, they found koa trees all growing there. Someone else must have brought them. But what could it be? We need to go out and collect some clues. Let's look closely at the seeds of other trees and plants. With the trees and plants in your backyard, maybe we'll find a clue today.
Here's my
Pick these yellow flowers. Dandelions. You might have seen these in your yard before. If you've ever noticed, you can see how after they flower, each flower turns to this. A little fluffy white globe. Each piece of flower has a seed on one end, right here. Watch what happens now as the wind blows. This video has been slowed down so you can see what happens to the dandelion seeds during a gust of wind. Here's another example. This is a maple tree, which you might also have in a neighborhood. See its seeds and what they do when the wind blows? And here's a fun example. This is a type of vine you don't have in your yard. It's found in the jungle of Asia. It grows this paper stuff around its seed. Here's the seed right here. Watch what these do as they fall from the top of the vine. So what do you think? Does seeing dandelion, maple, and the vine seeds give you any ideas how the koa tree might emit seeds from Hawaii to Reunion Island?
All right, so you know the drill. The question is, do you have any new ideas now? If you do, share those with your partners. Go. So do you guys have any new ideas? What are you thinking? Did you like the idea about the bird pooping it out? Or do you think it has to do with the wind? Make sure you're talking to a partner right now. And we're back. Who wants to share? Yes, ma'am, in the gray and white shirt. Really loud so people can hear you.
I flew around the world and it landed somewhere for some sand or some soil.
Okay.
And then it was wrong, and maybe it was raining, and then it kept on going.
So you mentioned a couple things. You mentioned soil and you mentioned rain. So it'd have to have something, one or two of those things around. So good for you. Who else? Yes, ma'am, in the back.
It could have floated away from it could have been carried by water.
Okay, we have a new thing here. She's saying that maybe the seeds landed in the water and was carried by the water. Anybody else have that idea? Carried in the water? So let's do this. Would you please, on your paper, give me your ideas now? If you agree that it blew, if you agree we're still hanging out with the birds at poops, or if you agreed that it landed in the water, or you have something completely different. You right now are a myth buster. You're trying to confirm or bust your myth. Give you about 62 seconds. Teachers, whatever you're doing in the classroom to get these answers right, you're doing the right thing. All right, guys, let's watch them again and see what happens.
The dandelion, the vine, the maple seed, all of these seeds are carried by the wind. There's a reason for that, too. It's actually good for each plant that this happens. Take dandelions, for example. This field is crowded with adult dandelions. They're everywhere. If the adult dandelions simply drop their seeds straight to the ground, there'd be no room for new dandelions to grow. So the seeds have to get away if they're going to grow and survive. We saw how each piece of fluff on the dandelion has a seed on one end. The seed doesn't weigh much, but it weighs enough that it won't simply fly itself. So each seed has its own little parachute made of fluff. By having this parachute, each seed can be carried by wind to a new field where there's room for it to grow. The wind will carry dandelion seeds for miles. Trees have to deal with another problem. If any,
Before we even start this part, it just said trees have to deal with another problem. Who wants to think or guess what they think that problem is by looking at the picture, getting evidence from the picture? Yes, ma'am.
I think when the trees get cut down, the seeds will probably fall out of the tree, and then they'll keep on flying until they go to another place.
Okay, so we're talking about maybe the tree being cut. Now, what other problem do you think may have? Yes, ma'am.
I think that maybe animals can make things. Some animals usually can climb trees.
Okay, so maybe animals climb the trees. Let's keep looking. I think most of you guys.
tree were to drop its seeds straight down, the seeds would land in the shade of the tree. At first it might not seem so bad, but that is a deadly situation for a plant, since all plants need sunlight in order to grow and survive. Maple seeds are bigger and heavier than dandelion seeds, and so a little fluffy parachute isn't enough to get them away from the shade of their parent tree. Instead, the maple seeds each come with a wing. This way they spin like helicopters, falling away from the shade of their parent. Without this wing, the maple seed would fall straight to the ground like a stone. The vine we saw earlier is also very tall, just like a maple tree. If its seeds fell straight down, they would also land in the shade and not get enough sunlight to survive. The vine seed comes with a wing, but unlike the maple, the wing works like a glider. So this vine uses gliders to send its seed away. These will fly even with the lightest breeze. That's perfect for the jungles where this vine lives, where the air is humid and still and there's hardly any wind. If the wind worked so well for the dandelion, the maple, and the vine, maybe it was the wind that blew the koa seeds all the way from Hawaii to Union Island. Maybe. But wind only blows seeds so far. Dandelion seeds, which are the lightest seeds there are, blow a few miles at most.
Oh.
To get from Hawaii to Reunion Island, we're talking about thousands of miles, halfway around the world. So it seems really hard to believe koa seeds would have been able to fly in the wind for thousands of miles. It wasn't the wind that carried the seeds. What else could it have been? Well, not every plant uses the wind to spread seeds. Look for some other clues, like this one, the palm tree. Let's get underneath it. Do you see its seeds? Here's one right here.
What
They're
is that?
coconuts. You think a coconut can blow away in the wind? No way. There's a good reason coconut palm trees grow near the ocean. Watch what happens to a coconut when it falls from the tree and lands on the beach.
Now, who said something about the seeds going into the water? All right. So, can seeds blow by the wind?
Yes.
Can they be carried by the water?
Yes.
Let's see if we can prove one more before we start.
Coconuts are large seeds. They're about the size of a bowling. There's no way they blow in the wind. Instead, we saw in this video how once they drop to the ground, a coconut gets picked up by ocean waves. On the water, a coconut floats, like a little raft. Ocean currents carry the seed far away, usually until it lands on another island. So if you've dumped a whole bunch of sand in the ocean and created a brand new island with nothing on it, if you come back to your new island in a few years, you probably notice coconut palm trees growing on it. Each coconut washes up on shore and sprouts into a tree. So palm trees use the water, not the wind, to send their seeds away. There are other examples too. This plant, called the sea bean, is another. Sea beans are a type of bean, and they produce the largest bean pods in the world. Forget those beans on your dinner plate. A single sea bean pod is bigger than your dinner plate. Each pod has little sections that fall away individually, like this. And each of these sections is a container wrapper. Inside of that is the seed. Like coconuts, these seeds float in water, and they'll float a long, long distance. Sea beans from South America have been found all the way on the shores of Australia. That's the other side of the world. So floating on the water, could this be the solution to the mystery of how the koa trees traveled so far? Let's finally look at koa seeds and see what we can find. Notice the seeds are in a pod. It even looks a bit like the sea bean. Sending seeds by water so that they're carried by ocean currents, that works really well for coconuts and sea beans. But not that many plants spread their seeds by ocean current. And here's why. The ocean is salty. Salt water kills most plants, unless the plant or seeds have special ways to deal with that. The part of the coconut that we eat, the white part, is the inside of the seed. But on the outside is a thick shell, that's the dark brown part of any coconut. And then surrounding that is an even thicker shell, called the husk. If you've ever seen a coconut for sale at the grocery store, it almost never includes the husk. That part is thrown away. So a coconut seed has all this protection from the salty water. That's why coconuts have no trouble with salty ocean water. And the sea bean, too, has both a thick shell and a protective wrap around it. Koa seeds? They hardly have any protective shell at all. We've even done experiments, and we see that they die in salt water after just a few days. They won't grow or sprout once they've been soaked in salt water. But in order to make the trip from Hawaii to Reunion Island, koa seeds would have had to floated in salty water for months. So as tempting as it is to think maybe koa seeds traveled on ocean currents from Hawaii to Reunion Island, it seems impossible. So we've seen that plants have ways of sending their seeds away in order to reach a good place for the seeds to find sunlight and grow. Some plants use the wind to carry their seeds, and others, like a coconut and sea bean, use water to carry their seeds. So wind and water are other ways plants move their seeds? There are. You probably recognize these. They're cherries. Cherries are a tasty berry, a type of fruit. But think about what went into them. You have to be mindful of that stony thing in the center. That stony thing, that's not just there to annoy you. It's the seed of the cherry tree. Here in the background, you can see the cherries while they're still on the tree. A cherry seems like a very unlikely seed to get moved around much. It has no helicopter or wings to fly, and it would shrivel up in the ocean. But every seed has some way of being spread. Do you have any ideas how a cherry seed might get spread? Well, let's think of what happens with a cherry. As a food, it's tasty, and not
What
just to
would you
human
do with a
beings,
cherry?
but to raccoons, squirrels, and foxes too.
What? Here's my animals.
Just like us, these animals have the pesky problem of enjoying the fruit part of the cherry, but not wanting to eat the stony part inside, the seed of the cherry tree. So you simply chew around it and then spit out the seed. So you see, now the seed has been spread. It's been sent away from the plant so that it might get sunlight and a new place to grow. The animal has done the work for the plant, even if the animal doesn't realize it. So animals are a third way some plants spread their seed. There's wind, there's water, and there's animals. Whenever you see plants with fruits or berries, you can know that it's an animal which is doing the work of moving the seed away from the parent plant.
So how many of you thought that it was wind? And that does work, right? How many of you thought it was water? How many thought it was an animal? All right. So let's see, actually right here, which animal it was.
A bird.
So no one knows for sure, but scientists think that it's likely a bird ate the seeds and flew them across the globe. I know what you're thinking. You don't go very long without pooping, right?
No.
This particular kind of bird is called a petrel. It flies across the ocean. It flies around in both of the oceans. And it sometimes eats seeds, and it can hold it in its stomach for many weeks. We can't do that. We'd be very miserable little people, okay, if we never pooped. But this bird carries seeds. And after a couple weeks or a month, she actually poops. And that's how scientists think that the koa tree got planted there. Yes.
It can travel by wind, hands, and animals and water.
Yeah, but it could be hands too. Absolutely. We're actually going to work on making some of these ways that seeds move, okay? So what we're going to do first is we're going to do the glider. Now, teachers, right over to your right, to your left, there are some sheets in the green bucket. And we're looking for the glider. But let's look for the center one first. They are crisscrossed. So students, here's what you're going to do. You're going to work with a buddy. And in just a moment, we're going to spread out around in this place and then over there at those tables. And with your teammate, you're each going to make a center that's going to represent a seed. As soon as that seed is made, we're going to come over here in a big group and we're going to fly our first seeds. You should have scissors. So there's a direction page, and then there is a template that has enough for everybody, and there should be some paper clips in there for some of the rest of them, not this one. All right, so those of you at home, get your glider out, your PFs, and your scissors, and let's make some seeds. So teachers, I'm going to let you maybe call groups, come over and get the paper, and then they're going to make their So class? Yes. Stop. Look. Listen. Teachers are going to call you. You're going to walk over there and get one direction per team, and then two of the templates. We're going to walk around. We only have about 6 minutes to make this first seed. So you've got to get with it. Can't talk about what happened last night, what's going to happen this weekend. We are all about the science. You are not star. Please stand. Ooh, I want to stand. All star.
All star, you are already paid. Everybody else is catching bubble. He's not going to okay. Sit down. We are sitting
Can I unplug you? Can I unplug you? I can move on.
Yeah, but the camera is back. Now it's been us. Okay.
Guys, make a line, please. Make a line. Not a group. Make a line. You guys, partner. I'll get you guys some directions. Hold on. Who's partner? Here. Who's partner? Okay. Here, you one. We'll see your pronouns anymore. Guys, partners. I'm gonna get directions in a second, okay? I'm gonna get you directions in a second. I get you directions. We're bringing information over here. We have some. Get it. Bring people beside me.
Yeah, we.
Don't forget number two. You have to read number two. Who needs the directions? Kayla, you need it. Read number two. Read number two. Read number two.
Okay, let's just
No. What do you Yes.
Really? You guys are still cutting more.
We got it every
No, you don't have to, but he was just talking.
No, I asked him a question.
All right, here we go, class. I need, and your team can help me. I need about 5 people from here that managed to walk over there and be a scientist.
Connor, Sarah, Miller, Elizabeth, and Mason C.
Okay, guys, it's on this side. This side is refrigerator. Show you what they have so you can see what step you might miss. Walk on over. If you need it, raise your hand. All you're doing is doing a visual tutorial, just showing off the look. We have 30 more seconds and we're going to walk over here and climb. Make sure your name is on You can just make one of them now, put the other ones into your journals. You can make this later. All right, guys, because we have other ones made, I need everybody, no matter if you're finished or not, everybody to leave your stuff on the floor, bring your seed, and let's walk over here and disperse them. So everybody stand up right here. We're going to stay right here. Spread out just a little bit.
Guys.
All right, here we go. So first of all, someone raise their hand and tell me the name of this type of seed that we're working on right now. Yes, ma'am.
Maple.
Okay, and what was the name on your pattern that you're using? Yes, that's the blue.
Me. Spinner.
Spinner, okay? So I want to spread out just a little bit because Miss Tyler's going to be filming this and she wants to see it. So you guys are the tree, okay? You are the tree. So you're holding your fish parallel to the ground so that the circle in the middle, the hole in the middle is parallel. Remember, you're making a pair of L's on the ground. Now I need everybody to back up a little bit more so they actually float. So you guys up there, if you can back in that area, I'm going to count to 3 and we're going to drop them, but we're not going to move. Now you wrote your names on them, so we'll be able to find them in just a few minutes. But I want you to drop them, but then I don't want you to move. Let's spread out one more time. Just kind of move back a little bit. 1, 2, 3, drop. First of all, did anyone have a seed that went straight to the ground?
No.
Not many of them. If yours went straight to the ground and you were holding your seed not parallel, okay, wasn't forming a pair of L's from the floor to your hand. Pick it back up again. Now, this is a little hard to see, but I want you to look on the floor right now and see if you kind of see your shadow. You are the tree, and the danger zone, or the zone of danger, is the floor where your shadow is. Trees do not want their seeds to fall in that zone of danger, because then they will not grow. Because all seeds, well, we're going to say most all seeds, because there are some exceptions, but most all seeds need what to grow? The sunlight. Okay? They don't all need dirt. But they do need water and stuff. So we're going to try that again. And this time I want you to, in your head, I want you to count. As soon as you drop it, 1, 1,000, 2, 1,000, 3, 1,000. See how long it takes for your seed to touch the ground. Now do that in your head, okay? So we're going to go 3, 2, 1, not yet, drop. That's what we'll do, okay? Ready? As high as you can get them. 3, 2, 1, drop. Alright, pick it up. Class. Yes. Stop. Look. And listen. Here's your assignment. In just a moment, you're going to tiptoe back to your area for 2 minutes. All you're doing in your journal is telling me what happened. Tell me what you did and how it got to the ground. Telling me everything that happened in 2 minutes, and then we're going to try another scene. Go. All right, I'm looking for those scientists. They're writing down everything you did, what that means for seeds, how they get dispersed that way. Did yours fall into the zone of danger, or did it go away from the tree, which was yourself? So, scientists, the next thing we're going to do is we're going to give you another template, and this one's called a robocopter, which is going to give you another type of seed dispersal. Now, this one, you're each going to get your own sheet of your template. There's going to be 2 of them on there. Just make one of them for right now. And you're also getting a paper clip. That paper clip is very important to making sure that your robocopter works. I need everybody to make sure you read through the directions. You can work with your teammate, but our first job is going to make these next ones. And we're going to hand those out in just a moment. Your extra spinners can go into your journal. So if you have extra ones left, just slide the sheets of paper into your journal. So how is it working? Make sure you send me pictures and examples, drawings of your spinner, right? We're doing spinners to dacia.jones@dpsnc.net. I want to see it.
Here comes your next fraction. Scientists, here's your next task. Only cutting. Read that one. Here's your template.
All right, as soon as you get your copies, you may go ahead and start reading with your partner. These are a little bit more difficult. Okay. Scientists, if you do not have the second set of directions, just raise your hand and wait patiently. They're coming around. Read those directions. What do you need, guys? Where's your team? Who are you working with?
I'm working with
You put on the here's the picture. You need to cut it up first. Look at everybody else. Cut it out first. One of them is going to be. Read those directions. For each of you are making your own. So third grade, I hope you've understood a little bit about how seed disperses. We're going to do this one in just a moment, and then your teacher also has a third one for you called a glider. So try that one tonight for homework. In just a few minutes, we're going to sign off, but thank you for joining us today, and we had a great day so far. Thank you to Miss Tyra Dixon from Durham Public Schools, who has been my camera woman today. Thank you. So let's check your progress. Paperclip on the bottom. All right, so we have about 1 minute and 13 seconds left. You're going to join me for seamless Somebody should have an extra somewhere.
want me to do it? I'm live. Yeah, got it.
All right, do not throw yours. Hold on to it. All right, here we go, everybody. So with me, I'll help you with the final one. Let's hold them down for just a moment so I can see everybody's faces. So a couple observations that I have is that several of you said, oh God, this is so hard. Your brain doesn't work unless it's hard. Okay? I want you to imagine your brain is a rubber band. A rubber band does absolutely nothing. It's just sitting there. It does not work at all. The only way a rubber band works is if you stretch it. Then it puts it around something and holds it together. So we want this to be hard. That's how you learn. Your brain doesn't get any bigger. Doesn't get any bigger unless you work hard. Okay? So a couple of things. Anytime you're cutting out paper airplanes, butterfly templates, seed dispersals, most of the time you cut on the black solid lines. And you always fold on the dotted or dashed lines. Okay? So C folded in and then D folded on top of it, paper clipped it. So what I need you to do is I need you to hold it in the middle so that the paper clip is facing down. So hold it in the middle, right here, right in the middle. Okay? So if yours looks like B's going down, A's going backwards, or vice versa, and then these are folded. So I need you to back up just a little bit. Now here's what we're going to do. We're going to say goodbye to our other third grade classes that are joining us. And I will let you know that one of our classes is joining us today from Alberta, Canada. So would you just do me a real favor and would you wave to the camera and say, hey, Miss Graton.
Hey, Miss Graton.
All right, now turn back around this way. Okay? We're going to hold it up. It's 3, 2, 1. And then I want you to watch it move. You guys move back there just a little bit to spread out. I want you to watch it move. And here's what's going to happen. We're going to watch it move, and then I'll say pick it up. Then we're going to do it one more time, and I will say pick it up. And then you're going to walk back quietly to your table, and you're going to tell me what happened on your table. You're going to write it down. And then compare. How is this one different than the spinner? How is the robocopter different from the spinner? So we're going to do it twice. So let's hold up. 3, 2, 1, drop. Pick it up. Hold it in the middle. You want that paper clip, the heavy part, to be coming down first. Yeah, that's what you get. Okay, ready? 3, 2, 1, drop. All right, scientists. Everybody look at me. Listen. In just one moment, we're going to tell the cameras goodbye. Then she's going to give us a sign that says it's off. Once it's off, we're walking back to our seat and we're finishing up our writings. You're going to clean your whole area up. You'll have 4 minutes to do that. And then you're going to be back up here for closing. Okay. Those of you that are joining us out there, thank you so much for live Dr. Drizzle. It's been a great day with Little River Elementary School. So tell them goodbye right now. All right, students.